Good evening. Thank you very much, Professor G.P. Lee, and thank you, Kenobi, for sponsoring this event. Thank you, Cal IT, for sponsoring the event. Thank you very much for coming. These are great events for people in the community to learn about research that's going on at UCI and for UCI to network with startups and large companies in the industry. And so I think this is a great opportunity for us to get to know each other. I'm going to be talking some about work that's going on in my lab and related labs at UC Irvine in applications of nanotechnology to communications and biotechnology. And you'll see I'm going to talk some about my own lab's work and some about other work. And I think there's a lot of opportunity for entrepreneurial activities and startups. I can think of 10 ideas that could come out of this talk alone for companies, and it's a matter of time and bandwidth and commitment, but I think there's a lot of opportunities. And so with that, I'll start. My lab is focused some on carbon nanotubes, and Phil Collins has talked a little bit about this. So I'd like to tell you a little story. A nanotube is one of the smallest wires that you can make. It's a tube of carbon atoms. It's about 2 atoms across. And somewhere around 2004, a student in my lab came to my office that was growing nanotubes in the clean room here at UC Irvine. And she came in with her lab book and said, "Peter, I had this great result, and I really want to tell you about it." I said, "Well, go away, I'm busy." And then a couple weeks later, she came back, and then finally she kept coming back and back and back. And finally, after about a month or two, I said, "Okay, let's see what you got." And it turns out she had grown the world's longest, at the time, carbon nanotube, which was almost a centimeter long, and it's an atom. It's a wire that's a few atoms across. So that was, at the time, a very interesting result. Now, that student was Jenny, and she went on to do a lot of other great things, and she was actually the #1 employee at a startup I founded about 5 years ago that has since gotten investment from venture capitalists, the U.S. Army, the U.S. Air Force, the National Science Foundation exceeding $10 million. So this was the very beginning of that story. And I'm not going to tell you the rest of that story because we have lots of other new ideas for new companies. This tube got me thinking, what if you could make an antenna out of this? Because it's a long wire, and antennas are made out of wire. So can you make that into a nano antenna? And I have a couple of results to show on that. But the first interesting thing is that intellectually, Shulkinov was a Russian theorist in the early part of the century who calculated the properties of antennas. And it turns out if you want to know how an antenna works exactly, there's only one solution that can be done without a computer. And that's an antenna which is a wire which is much longer than it is wide. And only in the limit where it's much longer than it is wide was Shulkinov able to calculate the properties of that antenna. All other antennas made are calculated with computers. So this is an analytical result that he had. And I wonder if he would be excited about this, because it's the highest length to diameter ratio of any wire that's ever been made. Of course, he's dead. But on the other hand, it turns out, I looked into it, and it turns out his theory's wrong, because he didn't know about quantum mechanics at the time. It turns out quantum mechanics says that his theory is completely wrong, and if you go into the size where the wire is comparable to the electron wavelength, that the system behaves as a completely different kind of wire. So he may be rolling over in his grave now, because I'm telling you that his theory is actually not true in the limit where the wire is a few atoms across. So that's the first story. So we have talked about in some publications the quantum properties of one-dimensional wire. And because I spent a lot of time on the story, I'll just tell you about the conclusion. We're very interested in looking at how electric signals propagate along nanowires and nanotubes. And it's very different than how they propagate along regular wire. They propagate much slower, and they have a much different characteristic impedance. And actually, just last year, I was funded to lead a center from 10 different universities to answer this question: how do electric signals propagate along nanowires and nanotubes? We have, my lab does carbon nanotubes, graphene nanoribbons. There's a group that does semiconducting nanowires. There's a group that does metal nanowires. And we're looking at the RF, at the infrared, and at the optical, and also how to use DNA to assemble them. So we have a huge team, and there's a poster on this in the lab tour you can see at the end. And we're looking at how do these signals propagate. For example, here's a picture of a metal nanowire where light goes in one end and it propagates along the metal nanowire and it comes out the other end. So the metal nanowire is much smaller than the wavelength of light. So there's all sorts of ways that we can use nanotechnology to manipulate radiation. So that's one general theme that we're interested in. There are lots of IP coming out of that, lots of interesting commercial applications. Getting back to the idea of the nanoradio, the nano antenna, so we asked, can you make a nano antenna out of a carbon nanotube? And then I'm going to show you a video. And then this is another story. 5 minutes left, so that's good. So another one of my students, I asked him, can you use the nanotube and build a nanoradio with a nano antenna? He said, yeah, sure. So he did it. And I'm going to show you a video, but it's an interesting story about the video, because we put the video in our publication, which I'm going to show you. It was the first video to be shown in Nano Letters, which was the #1 nanotechnology publication. And so we set a scholarly precedent. And nowadays, all the journals have videos, and for talking heads talking about all their research. So not only do we do a nanoradio, but we also have moved scholarly publication into the YouTube area. Now, whether that's a good or a bad contribution to science, I am undecided about. But the video is pretty interesting, and it shows what the kind of projects are that we're working on. So this is a separate thrust of how to build a nanoradio. And I need the audio for this, please. Chris? Here we go. Audio, please. It's a radio. We need to hear the radio signal.
There's a button on the laptop that will unmute it. Then RF signals transmitted.
So,
my name is Chris Rutherford. I'm in the Peter Burke's lab at UC Irvine, and here we're going to demonstrate a nanotube radio. We have a signal generator that works as RF source. This is producing a 1 gigahertz frequency wave that's modulated, amplitude modulated by an iPod. The signal is then, RF signal is transmitted from the transmit antenna to the receive antenna through a bias and into a nanotube. The nanotube acts as a demodulator, and that the nanotube is biased by the battery at 1.5 volts. The signal is picked up by a differential amplifier and fed into the speaker. And here we have the nanotube radio. We block the signal, the RF signal, we block the sound from the speaker. Remove it, signal's back. Also,
so we'll pause the rest of that. So that is the single nanotube receiving a radio signal from the radio waves, and 2 minutes left, and it's converting it into a signal that you hear in a speaker. Now, that video is very honest, because we show you the entire system. And there's other groups that have also made signal processing components out of nano elements. This happens to be a radio signal processing component. There's another way you can do signal processing, adding signals, digital, etc. And the fact that they're nano is interesting, but it's not really technologically significant, because you can make a micro component that's still very, very small. It's still microns in size. So the next step really is to miniaturize the antenna, which Chris showed here, in the battery. So we have a long-term goal of taking the antenna off the chip and putting the antenna on the chip, And this is some work moving in that direction at Broadcom, but that's still a millimeter size antenna. And we'd like to move that down to 10 micron or eventually 1 micron and develop technologies that can fit a radio system, complete radio system inside of a single cell. So that's another interesting project that we're working on. Professor Lee also asked me to talk about bio applications. So I only have a minute or so left, so I can talk to you briefly about this. But basically, we have another thrust area where we're looking at the connection. We're looking at studying metabolism, bioenergetics with microchips. And there's a connection between metabolism and all these diseases that you've shown on here. And we're actually studying mitochondria. And there's a lot of connections there. I won't go into all the details, but here's one example of the connection between metabolism and biology. This is mitochondria from regular cells, and it's got these membranes that are wiggly. This is mitochondria from human embryonic stem cells, and it's got a membrane that is smooth. And biologists don't know why that's the case. Well, there's some connection between mitochondria, which is the power plant of cells, and the metabolism of the cells and the pluripotency of the stem cell, which the biologists don't understand. So we have some foundational IP on using chip-based technology to assay metabolism in very small sample sizes, and specifically mitochondria, which are the power plants that generate the energy of a cell. And we also even have 2 generations of prototype devices, which you're welcome to go see in the lab after the break. My students will be there, they can show them to you. So thanks very much, appreciate it.